In this video, I want to have a look at calculating the angle between two curves. So a little while ago, we had a look at calculating the angle between two straight lines, and we had this formula here. So if we wanted to find the acute angle between those two straight lines, and we called that angle alpha, then we'd know that tan alpha is equal to the absolute value of m1 minus m2 over 1 plus m1, m2, and m1 and m2 were the gradients of our two straight lines. So we're going to still use this method when we're talking about curves, but because curves' gradients change the whole way along, there's going to be an extra step in there. So let's have a look at an example. So our example asks us to find the size of the acute angle between the curve y equals x squared and the line y equals 2x plus 3 at both points of intersection. So to step us into this, we're going to have one curve and we're going to keep one of our functions as a straight line. So we can read off straight from here that our, let's call it m2, is just 2. The gradient of that straight line is 2. But the problem with our curve is that it depends where we're looking on that curve, what the gradient's going to be at that point. So first off, we're going to find our points of intersection. So we're going to solve these two equations simultaneously. So let's call them equations 1 and equation 2. Let's substitute 1 into 2. So we're going to have, if we're substituting this x squared in where the y was, we'd have x squared equals 2x plus 3. Now we want to solve that for x. Let's bring everything over the left-hand side. So we're going to have x squared minus 2x minus 3 equals 0. We want to factorize that. You can use whatever method you like, whether it's PSF or cross method or whatever it is you prefer. And we're going to have plus 1 and minus 3. So that's going to give us our answers of x equals minus 1 or x equals positive 3. I don't need my positive there, I can just write 3. So they're the x coordinates of our points of intersection. I also want to find my y coordinates. So to find the y coordinates that relate to those x ones, we're going to substitute these x values back into either of those initial equations. Doesn't matter which one, you're going to get the same answer. So let's just pop it in here. Minus 1 squared would just give us 1, and 3 squared would give us 9. So that means our points of intersection are minus 1, 1, and 3, 9. Now to find the angles between our curves at those points, we need to know the gradient of this curve at that point. So to do that, we're going to find the gradient of the tangent at that point, which means we're going to have to differentiate. So if we've got y equals x squared, we know that y dash is going to equal 2x. So we can then substitute in our values. So at x equals minus 1, y dash is going to be 2 times minus 1, so minus 2. And at x equals 3, our y dash, our derivative, the gradient of the tangent, is going to be 2 times 3, which would give us 6. So this is our, let's change pen color, this is our m1 at this point, and this is our m1 at x equals 3. So we've got two different things we're going to find, two different angles. So we're going to have to use this formula twice now. I'm going to get rid of this, oh no, I won't. So let's go at x equals minus 1. Let's have a look there first. So x equals minus 1, we're going to have tan alpha is equal to the absolute value of m1, which was minus 2, minus m2. So m2 minus 2 minus 2 over 1 plus m1, which was minus 2, times m2, which was 2. So if we simplify down what's in there, that's going to give us minus 4 over minus 3, so the absolute value of minus 4 over minus 3, which just gives us 4 over 3. So to find our angle, we're going to go tan inverse of 4 over 3. And to the nearest minute, that's going to give us 53 degrees and 8 minutes. So at x equals minus 1, or at this point of intersection, at minus 1, 1, our acute angle between the curve and the straight line is 53 degrees and 8 minutes. Now we also have to do that for our second point of intersection. So I'm just going to rub off this bit up here so we've got some space. All right, so at x equals 3, we're going to have tan alpha equals the absolute value of m1 minus m2, so 6 minus 2, over 1 plus 6 times 2. Simplifying that down, we'd have 4 over 13, and the absolute value of 4 over 13 is just 4 over 13. So alpha is going to equal tan inverse of 4 over 13, which is going to give us to the nearest minute, 17 degrees and 6 minutes. So this is the angle between our curve and our straight line at this point of intersection, and this is the angle between our curve and our straight line at this point of intersection. So I could have written my answer a little bit neater if I had a bit more room. But that's having a look at finding the angle between two curves.